I like to move it, move it. I like to move it, move it. I like to move it, move it. You like to move it. I like to move it, move it. I like to move it, move it. I like to move it, move it. You like to.
For this experiment, you'll need a plastic bottle with the bottom half cut off.
Hey, wait! Somebody help get me out of here!
Next, you'll need a ball. A plastic ping pong ball or any light ball will do. Not this time, you sneaky ball. I was prepared with my force field. Ha! Lastly, you will need a blower or a hair dryer for the experiment and to get rid of pesky balls. Once you have all the materials, put the ball in the cut-off bottle and then use the hair dryer to blow air into the neck of the bottle. What is happening is that the airflow through the bottle and around the ball creates low pressure areas in the bottle. This causes the ball to stick to the bottle. Note how the ball sticks to one end and the next. It is bouncing from one low pressure area to the next.
I like to move it, move it. I like to move it, move it. I like to move it, move it. You like to move it.
To perform this experiment, we need the one can of milk, a plate, and a knife. First is we're going to make one hole in a can of milk. As you can see, we can still get the milk out with one hole, but the milk trying to get out will be resisted by the pressure of the air trying to get in. They about balance, so nothing will happen. Now we're going to make two holes. But with two holes, it allows the milk to pour out smoothly because when the milk pours out, air enters the second hole. The milk can do what it likes without interference from the air, and vice versa. Piercing another hole opposite to where the milk comes out allows air to rush in, stops the vacuum forming and allowing the milk to flow freely. That's why it's easier to the milk to release or get out in the two holes. Thank you.
I like to move it, move it. I like to move it, move it.